Hello, friends. You are welcome to yet another video from YouTube channel Tech Guru Gautam Prasad on electric arc furnace. So let's proceed. Electric arc furnace is an industrial setup where the furnace uses electricity to generate high intensity electric arc for melting and refining metals, especially steel, primarily from the scrap material. So whenever it comes to the steel making from the scrap material, electric arc furnace is the choice. Electric arc furnace setup has been shown in this picture. As in, you can see there are three electrodes, and there is a cut set view of the electric arc furnace in front of you. There are three electrodes for three-phase supply. Three-phase supply is given to these three electrodes, and the electrodes are at such a distance from the scrap materials so that arc formation takes place, and due to this arc the temperature goes on increasing on in a very short period of time to a very high temperature that makes scraps melt uh, in the form of liquid, and this entire process takes a very short time. So the tilting mechanism is also there in the furnace for the tapping process, you know, and a refractory lining is there all around to protect the vessel from the uh, heat damage. So refractory lining protects the vessel walls from the damage due to the excessive heat, because inside heat is very high and that can melt the outer body of the uh, uh, electric arc furnace. The tapping hole is there. Here from the tapping is done, and slag is being lighter than the molten metal. It floats on the surface of the molten metal, and this slag is poured from this side, and the metal is poured from this side. Maybe there are two different holes to pass on these two different things. One is molten metal and the other is slag. So the refractory lined bowl shaped hearth is there. This place is called hearth, where this takes the maximum amount of the heat back because it is nearest to the electrode, and where this arcing goes on. This is a charging door. A charging door is used to charge the materials inside the electric arc furnace. This is the top cover, and this is movable unit. Uh, this can move, and these electrodes can also move up and down. And these are graphite electrodes of the made of graphite material, which can be at a very high temperature without melting. It can, you know, it can produce the arc and does the whole process. Gas is intense, amount of gas is produced in the process, and for the recovery of the gases, there is a flue gas line where from these gases are recovered and put to the gas holder sometimes. Once this steel is produced and tapped, it is poured into the torpedo ladle or the ladle, uh, conventional ladle, and then it is sent for the continuous casting, whereby it is uh, processed into it is casted into a slab or a billet or some structurals that is of that could be considered as the finished product, or sometimes thin strip casters are also there that directly casts them into the thin strips. That means rolling is not done. Without rolling you can cast the thin strips, and Many companies are following this process to cast thin strips. So, how this whole process of casting works, basically, you have ladle at the top, and then you have tundis in which the molten metal flows from the ladle to the tundis, and uh, there is a mold in which this tundis material is, poured in, and this goes through the. There is a shroud here, and this through this shroud it comes down into the mold, and the mold is oscillated continuously. So there is a mold oscillation arrangement, uh, and that keeps on shaking this place, this mold, so that material does not stick into the walls of this mold. And through this process down the line, it is cooled with the help of water. Water circuit is external to this, and after cooling, it solidifies and casted into different types of products like slabs, billets, and structurals, as I talked about. So there is a withdrawal mechanism and a straightening mechanism, because when it comes out, it is it has got an arc-like circuit, so it has to be straightened, and after straightening, this is the torch is there that cuts billet into the predetermined size, and this uses acetylene and oxygen gas to cut this billet or slab or whatever it is, and into a specified length of the pieces. So that's the whole process of casting, uh, how it works. How an electric furnace works actually. The electric arc furnace, uses high-powered electric arc created between the electrode and the material, that is the scrap material, to generate intense amount of heat. And the heat is so much in amount that it melts the scrap material uh, placed in the vessel uh, into the molten steel. Oxygen is often blown into the furnace to purify the steel. So extra amount of the carbon is basically burnt with the help of the oxygen, and a controlled amount of carbon only is kept in the steel. Key features of an electric arc furnace are following. A refractory lined vessel is there. So the furnace is lined with the heat resistant material to withstand the extremely high temperature. Electrode system is there. Graphite electrodes are used to create the electric arc, and without melting. Retractable roof is there. This allows for the easy charging and tapping of the molten steel, and water cooled circuit is there. And large furnaces are often water cooled to manage the heat, so the heat does not go beyond the specified limit that will damage the inside lining of the refractory or the walls of the electric arc furnace itself. So, in order to protect all them, this is water cooled to control the heat. uh, you have something like carbon and oxygen injectors, which helps to inject carbon and oxygen, and slag door is there to tap the slag. Electrode arm is there to hold the electrodes, and this also uh, has the arrangement to move it up and down, so that the distance between the between the scrap material and the electrode is maintained. You have graphite electrodes, then the movable furnace roof, water cooled roof is there, so that the temperature does not exceeds beyond this uh, specified limit. Off gas elbow is there. This elbow is used to recover the gases that are produced during the arcing process. So oxy fuel burner is there. So you have oxy-fuel burner and furnace cell that is also water cooled. Refractories lining and the slag is, as I told you earlier, it floats on the surface of the hot metal or molten metal, and is still a scrap that is charged into the vessel, and that keeps on melting after the arcing. And then you have eccentric bottom tab ladle is placed here. This is the steel ladle, and this is the slag ladle. This is the slag side, and this is the steel side. The steel ladle is little bigger in size, and slag ladle is little smaller in size because the quantity of the steel that is produced is more than the slag. And that is how this is quite efficient furnace that has lots of advantages. We will also see what are the advantages of having electric arc furnace. So the applications of the electric arc furnace is in steel making. EAFs are a primary method of producing steel from the scrap material. As I told you, it is the furnace of choice if we talk about the steel production from the scrap materials. Recycling, they play a crucial role. That means electric arc furnaces play a crucial role in iron and steel recycling operations. So mini mills, EAFs are commonly used in mini mills that recycle the iron scrap. What are the advantages of electric arc furnace? So it is energy efficient. EAFs are generally more energy efficient than the traditional blast furnaces. Flexibility, EAFs can melt different types of the scraps and other materials. Lower carbon footprint, EAFs have lower carbon footprint compared to the blast furnaces. So the carbon emission is lower in the case of the electric arc furnace, and now the compliance towards the carbon emission has to be followed by the uh, steel producing industries, and that has to be followed by all the industries. So all the companies who are producing steel, they have to minimize the carbon um, footprint. So the types of the electric furnaces are three-phase electric arc furnace. This uses three electrode uh, graphite electrodes with periodically, changing polarity. DC furnace, DC arc furnace use one or more graphite electrodes, and bottom electrode as anode. The bottom electrode acts as the anode, and the top electrode acts as the cathode, and the arc is produced in between to melt the scrap material. So hope you liked the video, and if you liked the video, don't forget to thumbs up, give a thumbs up, and if you are feeling like suggesting something to me, then you can write in the comment section, my friends, and do not forget to subscribe this channel to get you more links to the useful videos created in such a manner. My YouTube channel is Tech Guru Gautam Prasad. Thank you so much once again.